Hey everyone, it's that Math Magician. On this video, we're going to continue to look at our final review for our geometry course. We are still working through that PDF full of questions covering basically all the concepts that we've done this past year. Now we are currently working on problem number 4. We finished out A and B on the last video. If you want to see those, check out the last video. But now we're going to focus in on C and D. And I'm actually just going to zoom in on C so we can get to work on this problem here. Remember, number 4 told us to write and solve an equation to solve for our variable x. Well, notice here I have a right triangle and I know both of the legs. We have one labeled as x, the other as x plus 17, and then the hypotenuse is labeled as 25. Now, the first thing that comes to mind for me is a right triangle with 3 sides. I think I'd want to use Pythagorean's theorem, right? Pythagorean's theorem says take the 2 legs, a squared plus b squared, and it's going to equal the hypotenuse squared, c squared here. Now, all I really have to do now is just plug in my numbers, or my numbers in this case, the variables, the expressions there, into Pythagorean's theorem. So I could write this as x squared plus, be careful, this will be x plus 17, the quantity squared. Got to make sure I put that in parentheses. And that's going to equal 25 squared. So now I'm left with this equation here with one variable. I can definitely solve for x here, and I'm gonna need to use some of our algebra 1 skills. This is actually an algebra 1 concept that we're in now. Hopefully you remember how to do that. Now let's see, x squared I can leave as itself. Remember, x plus 17 squared is really the same as writing x plus 17 times x plus 17. So I'm gonna expand it like that to show you what's gonna happen there. 25 squared, well, that just makes 625. All right, so we have this expression, x plus 17 times x plus 17. All we really have to do there is just distribute that out. We could use a box, if you're familiar with the box method, right? We could set this up, put the x plus 17 on one side, the x plus 17 on the other side, multiply to get the inside pieces. Another way we can do this is just distribute out those expressions. So I could do x times x, that's gonna make x squared. X times 17 will make 17x. Underneath, 17 times x is going to make 17x's. And then 17 times 17, ooh, I don't even know that one off the top of my head. But it's okay, we got a calculator here. We'll plug that in. 17 squared, that makes 289. It still equals 625. So we're doing good here. Let's see if we can combine any like terms. X squared plus x squared. Well, that's going to make 2x squared. 17x plus 17x, that makes 34x's. Still plus 289 equals 625. Now, some of you might be confused at this point, going, what the heck? We did not do this in geometry, but this is an Algebra 1 concept. You did pass Algebra 1 to be in geometry. We should be able to do a problem like this. Okay, now our next step is we want to have this equal to 0. Equal to 0. It's the only way that we can solve quadratics. So let's put this equal to 0 by subtracting 625 on both sides. If I do that, my right side is now equal to 0. I still have 2x squared plus 34x. Now I got to figure out what is 289 minus 625. Whoops, let's do this. Answer minus 625, we see it ends up being negative 336. What I need to do now is I need to factor this expression here. Not this expression, this equation. I need to factor out 2x squared plus 34x minus 336. I'm trying to use the zero product property here, right? That's my goal. I want to get 2 factors so that I can solve for x. I think one thing that I can do here is definitely factor out a 2, right? Each of those terms that are divisible by 2. I'd be left with x squared plus 17x. Probably gotta get my calculator out for this. What is that number divided by 2? It ends up being negative 168, right? And that's gonna equal 0. Now what I wanna do is I want to factor out the x squared plus 17x minus 168. I want to factor it out into 2 products like that to help me solve this out. So let's see. I know that this should be, we should have x's there. Okay, this is a negative and that ends up being a positive. So that's going to be a positive here, a negative here. Now I need to think through factors of 168 that can get us to positive 17. And this is where you got to do a little guess and check, or you can look up factors of 168. Either of those would work here. But I'm just going to use my calculator real quick, type some factors in, see what we get. So first thing I want to try is, what about 168 divided by 8? Let's look at that number there. That means 8 times 21. 8 times 21 gives us 168. Can I get to 17 if I'm using 8 and 21? And I don't think I can, right? I think those numbers are too spread apart for us to get to 17x. So I don't think that's the one I'm going to want to use here. Okay, so, but that's all good. Let's try this. What about 168 divided by 6? Okay, let's see. 6 and 28. That is a little closer. But again, I think 6 and 28, I don't think I can get to 17 using those numbers, right? I don't think that number there is going to work for us. So let's try this. What about 168 divided by 4? Oh, that's definitely not going to work, right? 4 times 42? That's not one that's going to help us out at all. But I think we need to go the opposite way then, right? I think the opposite way might work out for us. Let's do this. What about 168? Could I divide possibly by 12? 12 and 14, it's a little too close. What about 9? No, 9's not going to work. 7. 7 gets us to 24. Uh-oh, I think this might be it. Look at 7 times 24. 7 times 24 makes 168. And if I put the 24 here and the 7 there, let's think this through, right? 24 times x will give me 24 x's. X times negative 7 gives me negative 7 x's. That right there is going to add to our 17x right there. That is definitely the factors for this quadratic. We have done it, which is awesome for us because now we just got to use zero product property. The zero product property says that we can take both of those factors and set them equal to 0. I actually don't need that parentheses there. We set them both equal to 0 and we solve now. The left side is going to be x equals negative 24. Right side is going to be x plus 7 equals 7, right? Just by adding 7 on both sides, subtracting 24, subtracting 24. Those are our answers there. Who knew? Let's zoom out. Who knew that this right triangle Pythagorean's theorem problem was going to involve quadratic equations, zero product property, factoring, all that hidden in this problem? Now, something that you should be able to do at this point, but you might have just needed a little refresher, okay? Alrighty, that is letter C. Let's go ahead now and jump into problem D here. D will be a little easier for us. We have here a pentagon. I know it's a pentagon because I see 5 sides. 1, 2, 3, 4, 5. Pentagons, they have 5 angles inside. Looks like we're given all the measurements for those angles, right? Look here, I know that this is 90. I'm going to write this out. I have a 90-degree angle here. This angle is plus 6x plus 4 degrees, plus another 90-degree angle there, plus the 8x minus 10, and then plus that final angle up there of 4x. These are all 5 of our angles. Well, pentagons add up to a certain number for their angles. Actually, they're always going to add up to the same number. If you forgot what pentagons' angles add up to, well, we have a magic formula for that. Remember 180 times n minus 2? That will always tell you the sum of the interior angles. N here in our case is going to have to be a 5 because it's 5-sided shape. 5 minus 2 gives us 3. And what's 3 times 180? Well, that is going to be 540 degrees. Look at this. There's the equation. We just got to solve it now. All we have to do is combine like terms. Let's start with our x's. I see 6x plus 4x is going to make 10x's plus another 8. That is 18x's. All right, 90 plus 90 is going to be 180. And then 180 plus 4 is going to be 184. But look, I got to subtract 10. So I'm at 174. It equals, not 180, 540 degrees. All righty. We're probably going to want to subtract 174 on both sides Doing so leaves me with 18x's equal to, let's get our calculator out, 540 minus 174. And I see that, oh, not 17. What is happening? 174. There we go, 366. I want x by itself. Well, I need to divide both sides by that 18, our coefficient. If I do that, let's get our calculator out one more time. Our answer divided by 18, our missing x value ends up being 20.333, repeating degrees. There we go. That right there is how we solve problem C, problem D. A little more trickier, that's why I separated it out from the other problems, but something you can definitely do. It's That Math Magician, and I'll see you on the next video.